Hello and welcome to a rehash of the cable SVN-Git Transition training that we held at the Access workshop. My name is Ben, Research Software Engineer in the LAN team of ACCESS-NRI. I'm going to be covering over much the same presentation we had at the workshop, plus some recorded examples of how to run some of these commands that you can do in your own time. So let's get started. So what is Git? So Git is a distributed version control system, DVCS, that enables collaborative development on shared code bases. It is probably the most widely used version control system in the world. What is GitHub? So GitHub is a company that has made good business in hosting remote Git repositories. So it's a web-based platform which permits additional workflow and collaborative features like issue tracking, release management, continuous integration, automated testing, all that good stuff. Now, it's important to note that GitHub is not Git, but it has become synonymous with it. There are a lot of other providers out there that do similar things, GitLab, Bitbucket, so on and so forth. But you will often find that the two words are often widely interchanged in the wild. So just bear that in mind. So what are the key differences of Git versus SVN? So in terms of distribution, SVN is a centralized repository of code, whereas Git is distributed. So each developer has a complete copy. In terms of structure and history, the central repository in SVN holds the history, whereas in Git, every copy is a repository itself and has the whole history up to the point that it was snapshotted. The commit strategy between the two, SVN is sequential, whereas Git is hash-based, and that hash is generated on a number of factors, but you can consider it to be more or less random. Branching and merging. So in Git, it is quick and mostly painless unless you have merge conflicts. And in SVN, it's much more involved and it requires a lot of planning to bring all the branches in and consider what is authoritative. Online versus offline. So with Git, because you have that benefit of your local copy being a repository itself, the commits can be made locally offline, say if you're on a plane, before pushing to a remote or central repository. Whereas in SVN, the connection to that central repository is required in order to commit your changes. So what are some key concepts? So in Git, we have what's called a repository, and you can think of this as just a place where code lives. We often just call it a repo. A branch is a parallel line of development allowing you to work on code in isolation from the main code base. So if you consider main as being the trunk, if you're looking at SVN speak, a branch is basically a snapshot from that point where you can work in isolation that you will then merge at some point. A commit is a snapshot of the changes that you have made to a given repository on a given branch. Merge, it's the act of reconciling changes made in one branch into another, such as bringing changes from your branch back into the main or vice versa. Clone, it's a copy of a remote repository for local development. Checkout, which is the act of switching to a different version of a branch or a file, etc. Pull, the act of pulling changes from one repository to another, i.e. from a remote to a local. And push, the act of pushing changes from one repository to another, i.e. from local to remote. Now it's bearing in mind that these are just a handful of the concepts around Git. Hop onto the Git SCM website, which I'll give the link for shortly, so that you can see the whole lot if you're interested. Conversely, or maybe in addition to, GitHub has a bunch of key concepts as well. Some of these are very similar to Git itself. So we have a repository or repo, exactly the same thing as what you would consider in your local Git installation, except that the code lives on GitHub. An issue is an issue or a task describing a proposed change to that repository. So an issue could be a feature request or enhancement, or it could be a bug that you want fixed. So it's basically just a task. A commit is reference to a commit that a developer has made using Git and pushed to that repository, usually with a meaningful message and typically in response to an issue. A pull request is a request to pull proposed changes from one branch to another in GitHub. So the example that we would have here would be you've made some changes on a branch, which you push to GitHub, and then you initiate this thing called a pull request to then take those changes and merge them into the main code base. Because we can't work on main directly, we work in isolation before using GitHub to merge. Review. So we consider this to be constructive discourse or feedback on a proposed change. Here we are with Git. Here are some basic commands. Now this next part of the video is going to get a little bit choppy as I switch between the presentation and some live demo. So just bear with me. So the basic commands: git init, clone, fetch, add, commit, merge, status, log, pull, push, checkout, branch, and rm, remove. This is just a handful of the commands available. There are lots and lots of parameters for these as well. So check out the gitscm.com docs for further information. So the first command that we're going to cover is git init, which is the command you would use to turn a regular old directory into a Git repository. So as an example here, create a repo or create a directory, move into it, and turn it into a Git repository. And here's the video for that. Okay, so before we get started with all of our Git command examples, we're going to create a little workspace to run these commands in. So I myself like to have a work directory in my user home. So we're just going to work from something like that. So we'll say make dir -p work, and we'll say git demo. So we now have a git demo location. So we're going to move into that location, git demo. And we can see there is nothing there. There is also nothing Git related if we use the git status command. It's not a repository. So in order to turn this into a Git repository, we need to run what's called the initialize command, which for Git is git init. Git init. So if we run that command, it says that we have created a repository at this location. And to prove that, we can say git status again. And we can see that we're on the main branch. There have been no commits, and there's also nothing to commit right now. So our Git repository is now ready for us to do some work. Okay, moving on. The next command, which we are going to have, is git add. This is where we do some work in our repository, and then we add it to that repository. So in this example here, we create this file, we add it to the staging index. So we can consider Git having a two-step process for committing. One is to stage the file, and the next one is to commit it, which we'll cover shortly. And that add command takes a path specification, which is, you can think of it like a regular expression, but it's basically like the glob expansion in Unix. So here's a video explaining that. Okay, so following on from the previous example where we initialized a Git repository, we're now going to work the process of creating and committing a file to our repository. So just to reiterate, we can do a git status and see that there is nothing on our branch that we have done. There are no commits yet. There's nothing to commit. So we're just going to do a simple example of creating a file. So I'm going to say, I'm going to echo, hello, my name is Ben. And I'm going to send that into the ben.txt file. Now you can use your name, you can literally write whatever you want. The point is that we are creating a file. Now this could be your source code that you're putting in as well. So we echo that file out, and it now exists. So we have a look, there is a ben.txt file. Now, what we need to do next is we say git status, and we can see that the return of that command is very similar, except it's now saying that we have some untracked files in our repository. Now, this is what happens when we have new files. If we have modified files, we get a different listing in there as well that says these are the modified files. So what we need to do is commit that. Now, the way that Git handles a commit, it's kind of a two-stage process. So what you do is you stage a file that you've committed or modified, and then you commit it. So we'll do the first part of that now, and in the next example, we'll show you how to commit that file. So it's quite straightforward. We literally just say git add, and the add command will take a path specification or a path spec, which means you can use something like star.txt to get all the text files. I could say ben.star to get everything that says ben at the front of it. You can say add, add dot, which will add everything that is currently untracked, save for those things that are listed as to be ignored in your gitignore file. But for clarity, we're going to say explicitly, we're going to just add that file. Now, we don't get any return from that command. It did work. But now we can say git status, and we can see that there is now a change to be committed. Now Git's telling us that we can remove that if we want, but we'll ignore that for now. And now we're ready to move on to the commit stage. Now we're back. Commit. So committing is where we take all of the stage changes which we used with git add, and we basically take that as a snapshot and write that into the Git history. So the quickest way to do that is to use git commit -m with this message, and you get extra points for referencing a GitHub issue, which we will explain in a minute, as this activates magical links all over GitHub. So here is the video explaining that. Okay, so here we are on the next step of our committing workflow. So we've added our commits, or we've added our file to be committed to the staging section of our repository. And now we need to do the next stage, which is committing. So just to reiterate, we can say git status, and we can see that there is a file there that is to be committed. Now Git's telling us that we can unstage that should we want to, but we're not going to do that right now. We're just going to follow through the workflow. So in order to commit that file, we say git commit. Now, if we were to run this command as it is, then Git will open up whatever your default editor is, be it Vi, Vim, Nano, or similar. And you'll just basically fill in the message of explaining to others what it is that you did, and any caveats you might need to do, and then you close that and it'll write that as the message. More often than not, though, you will see people just put a one-liner in. So we can use this -m flag, and we can say what we did. So created ben.txt file. Now, the other thing that we can do here is if we are working on GitHub, which we assume you are in this training, then if you were to put the GitHub issue number in here somewhere, then it will activate a whole bunch of magical links across GitHub. So you might see the terminology fixes issue number, whatever the issue happens to be. And then once this commit gets pushed up to the repository, then that's going to activate a whole bunch of links. So you can go from your initial issue all the way through all the commits to find what was done. So we'll ignore that for now. And we'll just say, created that file, done. Now that is telling us that we have created a file. So if we say git status, there's nothing to commit. Where'd it go? Well, it's still there, but it is now part of the Git history. So we can use the command git log, and it tells us that at this point in time, this commit was created, and there's my message there with created Ben. We are on the head of the main branch, and we get this random commit hash, and that is history. That is set in stone. And we're back. Next, we have git status or git log. So these have been covered a little bit in the videos already. But basically, check the status of the repository, including all unstaged changes, etc. Show the log of the commits if you want to see the history. And the bonus is to figure out who broke things and when. So you can give a path specification to git blame, and you can get the full history of changes to a given file and who did them. So here is an example of git status and git log. Now, as you will have seen, and perhaps some commands that I didn't explain just yet, there are a few commands that you'll find yourself using fairly regularly as you move through your Git workflow. Now, these are status and log. So just to show you what they do, git status will show you the status of your working directory. It'll tell you some information about what branch you're on, any other things like modified files or deleted files that you are working on at the moment. So git status is kind of like, where am I up to right now? The other command, which you saw me use in a previous video, is git log. Now git log will show us the history and the snapshots that were made. You can add some additional flags to this to get some more verbose output, but this can be useful just to sort of see what were the most recent commits on this particular branch. Now, the other fun one, which is a bit of a bonus one, is let's say you're working on something and you're not quite sure what happened, but something broke. Maybe your code no longer compiles. Well, there is a command called git blame. So we can say git blame ben.txt, and this will tell you all of the changes that were made to that file and who did it. Now that can be very useful. I mean, it's not necessarily, it sounds a bit sort of nefarious to say who's to blame for this, but it is useful if you're working in a collaborative environment. Maybe someone made a change that they weren't sure what the repercussions would be. So that is a useful one. And also just for yourself. So you can say, when did I break this? Moving on. The last command here with these simple examples is git rm. So this is where we want to remove a file from the Git repository to stop tracking it and delete it. So we would use git rm and we give it a path spec. Here is an example. So up until this point, we have shown the example of how to create and commit a file, but what about deleting them? Now, this might be useful in the case of where a file no longer is relevant to you. Maybe the code that is in it has been moved elsewhere, or perhaps you added something to the repository that you didn't mean to, and you need to clean it up in the very next commit. Usually if you rename a file or move it, Git is smart enough to know that it was deleted in one place and created another, and it does those commands for you. But let's just use the example of deleting a file intentionally. So we have a file, ben.txt. So if we were to just remove that file, ben.txt, we can see it's no longer in the repository, but it is still part of the history. So Git knows that there was a file there called ben.txt and you deleted it. Now it's giving you a series of commands that you can work on that deleted file. Now the one that we're interested in is git rm, so git remove. So if we say git rm ben.txt, it's now saying you're removing that from the history from this point, not from forever, but from this point. So now if we say git status, it's saying that this is the change to be committed and it is deleted. Now, interestingly enough, if you look up above there, how it says git add/remove file, the add and remove command will do the same thing on a deleted file. So if we follow Git's example here of restoring this file, git restore staged ben.txt, and then we also do git restore ben.txt to bring it back. It's there. If we say remove that file, ben.txt, but then add that deletion, we get the same thing. So git add and rm work the same on delete files. So now if we were to commit this change, we could say we deleted this file. It's now gone from the Git history from this point onwards, Now, that's not to say that someone couldn't get it back from previous history, but this is just the current checkout from this one. That file is now gone. Now, I'm going to restore it for our purposes, but just going forward, that's how you would remove a file. And we're back. Now we're going to talk about branching. So we'll explain what a branch is in the video coming up, but here are just some basic commands that you have. So we're going to list all the current branches in your local repository with a git branch. We can create a new branch with git branch and then the name, and then we can delete a local branch safely. So that is what we would use when we want to clean up some leftover branches. So here is a quick video on the workflow of using branches. So up until this point, we have been working on what's called the main branch in Git, and the real power of Git comes in this branched development model that it has. So if we have a look and we say git status, we can see we're on the main branch, branch main. Now, if we think of main as kind of the central line of development in a Git repository, a branch is a snapshot of that main at some point where you broke off, started doing your own work, and then at some point you would merge that back in to main. This allows developers to work in relative isolation from each other, meaning that they can make changes as widely as they want without affecting that central source of truth. So if we think of it in terms of SVN language, it's essentially the trunk. So there are a number of ways to work with branches in Git. So we'll cover a few of them now. So the main command that you might use is just git branch. So if we run that, we can see that there is a main branch, and the little star says that's the one we're currently on. So in order to create a branch from which to work, we say git branch, and we give it a name. So I might say my branch. Now nothing happens from that command. It did return successfully. So if we say git branch again, we can see that there is a branch there. Now we're not currently on that branch. We're still on the main. We've just had a snapshot. So it's kind of a two-step process if you follow this particular workflow. Now, to get onto that branch and start working, we say git checkout. And we give it the name, my branch. And now it's saying that we're on our branch. So if we say git status now, on branch, my branch. Nothing to commit. Working directory is clean. So here we can do all our work. We can make as big a mess as we like. And then at some point we'll merge that back into main, and we'll cover those commands shortly. And everyone who is relying on main can continue to do so. Now, once you're done with working with your branch and you've merged it back in, the other command, which we'll cover here, is to delete your local branch. So you say git branch delete, so -d, my branch. So this is kind of to clean up after yourself so you don't end up with a whole bunch of stale local branches. You've already pushed it up and merged and done all that great stuff, but you don't want to have all these random branches sitting there. So you say git branch delete, my branch. Oh no, we can't delete it because we're currently sitting on it. So if you think about the analogy of a tree, you cannot cut off the branch that you're currently sitting on. So in order to delete that branch, we need to move back to the main. So git checkout main, or to another branch. Typically you go to main, and now you can run that command and it's gone. So if we say git status, we're on main. We say git branch, it's gone. Moving on. Checking out. So a shortcut for branching, which I think I've covered in the video so far, is to use the checkout command directly to check out a branch and switch to it. So it's git checkout -b with the branch name. There's also the other benefit of using checkout to wipe your local changes and start again. So this could be an example of where you've gotten yourself a little bit lost, you're not sure what's changed, and you want to just get back out to a working copy when you first started this little piece of work that you're doing. So you can say git checkout path spec, and there are a number of different arguments that you can give to that to trigger it. Now, the other part of this, you can see that was a bit of an involved process to get off and on branches. Now, there is a shortcut in order to do this, and that is using the checkout command directly. So I'll just clear my screen. So we can say git checkout, and if we give it a branch name as part of it, it's going to create that branch and switch us to it in one command. So if we say git status, we're on that branch, git branch, whoops, and there we are, we're on the my branch. Just a little shortcut for you. The next is git merge. So merging is where you merge one branch into the currently active branch. So the branch name. So in this example, and what is covered in the video, how to merge changes from a branch back into main or vice versa. Now, just bearing in mind that most of the merges we will be doing will be handled through GitHub itself, but it's good to know how to do things locally. Here is a video. Okay. So the other part of the branching strategy, which I sort of hinted on in a previous example, was merging your branch back into the main line of development. So let's say you've finished doing your new experimental change on your code, and now you want to merge that back into the main line of development. So we're going to work through the strategy at the moment of branching off, making a change, and then merging back in to that main branch. So I'll show you an example here. So if we say git checkout, we'll use our shortcut here, check out my branch, we now have a new branch. And from here, I'm going to create a file. So let's go echo, hello, my name is John. Okay, let's say John. And we say john.text. Okay, so if we say git status, it's going to show that there is a file there that hasn't been tracked on my branch. So we're going to follow our strategy to add it. Git add John, and then we say git commit added John, john.text. Okay, now that exists on my branch, so you can see that it's there, but it doesn't exist on the main. So just to prove that, we're going to git branch, we're going to git check out the main. I'm going to have a look. It's not there. So it is stored in Git's history, but on a different branch at the moment. So in order to bring that in, we need to do a merge. So we're going to merge my branch into the current branch. There we go. So it's fast forwarded that and it's created a file and it's got one insertion in it and it's brought it here. So now if we have a look, we have now john.text. Now this works in both directions. So if you are trying to update main with a branch, or if you're trying to update your branch with changes that have happened in main since you last snapshotted from it, this works in both directions. And you'll find that it is useful to use from time to time, particularly if you need to incorporate main changes regularly into work that's maybe taking a little bit longer than planned. So that is how you do a merge. Now, the flip side of this is a lot of the merging that we're going to be doing is going to be happening through the GitHub interface. So we're going to do pretty much all of our work directly on feature branches, which are branches that are not main. And we're going to push those branches to main and allow the GitHub interface and issue tracker and that whole conversation engine that they have there to facilitate the merge back into main. So we won't be able to merge directly into main of the cable repositories. That's all going to happen on GitHub, so there's a bit more of an approval process and a bit more sort of stringent quality controls as well. So, yeah. Next, cloning and fetching. So in order to work on a remote repository, we use the clone command. So git clone the repo URL, and then you optionally can give it a local directory, which it will create. If you just leave it blank, it'll be whatever the path slug is in that URL. Likewise, we have fetch, which will download commits, files, and refs from a remote repository into your local copy. And here is an example. So up until this point, we've been working on our own on a local Git repository. The way that it's going to work going forward with cable development is we're all going to work on a shared remote repository. And in order to do that, we need to get a copy of that shared remote repository, which is hosted on GitHub. Now, all the commands that we're going to use, exactly the same as what we're going to be using locally, except we have a few additional ones in order to interact with the remote repository. So the first one that we have is git clone. Now, what that is going to do is it's going to bring down this repository, and I've just copied that URL out of GitHub. It's going to copy that down, and it's going to put it in this land git training 2023 folder when it does it. Now, if we run this command and we want it to go into a different location, the next argument you give it is the local directory that you want to put it in. But for our purposes, we're just going to put it straight into whatever the default is, which is land git training. So it says it's cloning into it, so it's created that directory. It's now pulling down everything that was there, and now we have a local copy of that remote repository. So if we move into it and have a look, here we are. We've got a few files in there from the things that we've been doing. So if we do a git status, there's nothing there. If we do a git log, you can see there's a whole bunch of stuff that has been done previously on this repository. So we'll just clear that. And here we are. Now, the other command that you might find yourself using when you do this, and what Git tells you to do, is a fetch. Now, what does a fetch do? Git fetch will bring down any references to branches, tags, etc., and bring them down locally. So you find that when you create a branch on GitHub, you might want to use git fetch to get a hold of that. Now, that's probably not going to do anything right now. I don't think it will, because there aren't any live branches there at the moment. So if we have a look, git status, we're all there. Git branch, there's nothing going on. And we're back. So git pull and git push. So this is where we would use these commands to basically get changes from a remote repository, which we do not yet have, or push changes that we have that the remote repository doesn't have. Okay, so the next command that you'll find yourself using when you're working in a remote collaborative way is using the git pull and git push. Now, what do they do? So git pull, essentially what it's going to do is it's going to look at the remote repository, taking into consideration what branch you're on, and it's going to pull down any committed changes that you do not yet have in your local copy. So when you run that, it's going to check the differences and it's going to return back whatever you don't have. Now, it's good practice to do this before you start doing any work, because when you do a git pull, Git's going to struggle with merging things. So if you have uncommitted changes locally, it's not going to be able to interpolate those changes and reconcile the differences. So if you just say git pull, this isn't going to return any problems at the moment because we are up to date with the remote, already up to date. Now, the inverse of that command, more or less the inverse, is git push. So what this will do is it will look at your local repository and it will bundle up all the changes that you have made since you last cloned or pulled, and it will send them to the remote repository, which will either accept or reject them. So in the instance where your changes are new and they fit nicely on top of the history, then it will accept them. It will reject it if other changes have come in while you've been working, and it can't reconcile those changes. So it'll force you to do an update locally before you try and push it. So if we say git push, everything's going to be up to date here. Now, we're going to cover an example of what happens when you've got those changes that are reflected in one place or the other in a subsequent video. But just so you know what git pull and git push do, here's just a quick one. Next. Something that we haven't quite covered yet is this idea of a gitignore file. So this can live in the root of your repository, .gitignore, so it's a hidden file by default, which will tell Git what files you want to ignore from any of your Git tracking. So if you were to use something like a git add dot, then everything that doesn't match whatever these patterns are in this file will be added. Whereas this file, and here's an example just from GitHub of the one that's used for Python code. So there's a bunch of things that you may not necessarily want to commit to the repository, like build artifacts, or just you could even include things like, say, your editor adds a whole bunch of random guff into the repository that you don't want to commit. Then this is what you would use to ignore that file. No, ignore those files. So this is just a file that lives in the root of your repository. The cable one that you will be working on in future will have a git ignore specified. Now, we've covered the process of making commits. So basically, to recap, there is a 3-step process to making a commit in Git. In Git, you must make your change, stage them for a commit, and then commit them. And it's good practice to use that git status and git log before and after you have staged and committed your changes, just so you know what's going on and you can be confirmed that you did things in the right order. A remote repository. Now, we've spoken about git fetch and pull and push, but just to recap, a remote repository is a shared remote repository that enables collaborative development between developers. So if we use that diagram on the right-hand side there as an example, developers push and pull changes to and from remote repositories, and they share and update code. So in GitHub, you would have a branch that exists both remotely and locally that you work on. You push to said branch, and then when you're happy with that branch, you would then try and merge it into main using a pull request. There are a number of collaborative workflows. So the one that I just showed you is one that's very close to a concept called OneFlow. We're not going to cover these here just because it can get confusing, but just for your interest, these are some different ways that you can work with Git. What are some best practices with working with Git? Your branches should be short-lived and remain current. So you want to make sure that you are working not necessarily quickly, but in small, manageable chunks so that you can regularly integrate back into that main branch. And you want to remain current, so you want to update frequently. You want to stay on message, so keep the changes relevant to the issue. So, of course, we're all guilty of, you find a bug and suddenly you need to change code in a whole bunch of places. Try to limit that as much as you can. But on the flip side of that, if you do discover a bug, fix it and then just make a note of that as you're making your commit history going through. Following on from that, it is good practice to raise subsequent issues for additional work later. So say you find something that's maybe not necessary, say a bug fix or whatever for what you're working on, but it's something that you'd like to do in future, raise that issue. Run any tests before committing your changes. So if you have tests sitting in the repository, say you're working in Python, run your PyTest before committing the changes, because you might need to make some fixes before you commit anyway. And we're all guilty of this. You often see a case of someone makes some commits, run some tests, some of the tests are broken, they fix those tests and they commit again. So you see there's some commits in quick succession as they're making their tests pass. Create smaller, more granular commits. So it's better to make multiple little commits and even push them regularly to your remote branch just as a backup strategy. So if your computer catches fire, you've got a copy stored elsewhere. And keeping them granular means that your changes can be rolled back more readily. So in essence, create regular, frequent commits with meaningful or semantic messages. So rather than just saying stuff, be explicit with what you've changed and what you've done, which may not be immediately apparent from the code diffs that come up. And you get extra points if you reference that GitHub issue number, so the hash issue number. Make sure you pull changes and reconcile any conflicts locally before trying to push to remotes. This is just going to make everyone's job easier. And clean up stale branches, especially when merged into the main branch. Otherwise, you will end up with hundreds of branches just sitting there in your local repository and you won't know which one you're working on. we've actually activated on GitHub itself to delete stale branches once merged remotely, but that's not going to fix what's happening locally for you. And always work in feature branches. People will not be able to push directly to main. Main's going to be protected, as we say there. So main branches are push protected. Cables will be if it hasn't already been switched on by the time we're recording this video. So the live exercise, what we're all here for. So in this example, we will show you, or what we did show you at the training, setting up Git for the training, clone the training repository, create an issue on GitHub, create a branch for that issue. You need to be a collaborator to do this. Make changes and commit to your local copy. Push the changes to the remote and kick off the review process, dealing with merge conflicts. Okay, so the prerequisites. We're assuming you know how to use a terminal or connect to the Australian research environment on Guardi. You have an account on NCI. You have a GitHub account. You have the SSH keys set up on GitHub. You're a collaborator on that repository. Now, if you answered no to any of these, please pause the video and maybe take a look and see if you can figure out how to do that. We do have some extra code examples that will help you work through. So here we go, setting up SSH keys. So if you haven't already set up a public key, you can skip to, sorry, if you have already, you can skip to stage 3 here, but otherwise you run these commands and you should be able to clone from our repository. So you can pause this video and run these commands, and then we can move on to the next step. Now to set up Git, now let's assume that you're on Guardi, but you could just do this locally. So we want you to connect to Guardi, ensure that you've configured Git with your details here. We like setting this automated tracking against remote branches setting. It just makes things a bit easier. And for the purposes of this training, you can create this work directory. Now, a lot of this is going to carry on from the videos that have already been done earlier in this video, but this is just to reiterate what was done on the Access training day. So clone the repository. Now we're going to create an issue on GitHub. So I've created a short video to do this, which I'll put after this slide. But otherwise, here is just what you do. So navigate to the repository, create an issue, create a branch from that issue, and then enter those commands into your repository. And just remembering that origin is the default name for the remote repository. All right. So in this example, I'm going to show you how to create an issue on GitHub and a subsequent branch for that issue, which you can then use to check out and do some work. So if we use the land Git training repository as our example, this is what you're presented with when you just land straight on that website, on that web page. And from here, we can go up onto the Issues tab just here. And if we hit that, we're presented with the current issues that were going on. We hit New. And from here, we can describe our issue. So I'm just going to say test issue. Maybe add a little bit of information there. Test issue for training, ... And we can now hit submit issue. Now that's created that issue on GitHub, issue number 13. Now the other fun thing about this particular page is now that we've created that issue, we now have access to this little link here that says create a branch for this issue or pull request. So if we click that, get this little pop-up, gives us a few options. So if we check out in code space, we can edit directly in GitHub. We're going to ignore that. We can open the branch with GitHub Desktop if you prefer a user interface version, but we're just going to check out locally because that follows this training quite well. So if we say create branch, it's now created the branch on GitHub, but it's also given these commands to run locally. So basically what we would do in our repository is we say git fetch origin and then git checkout test issue. And now what that's going to do is it's going to copy the repository at that point, and it's going to switch us to that branch, which will be remotely tracked against that issue. So you can do some work and commit. So we can do all this wonderful stuff, and we can push it to the remote. And then the process of creating a pull request. So we can navigate to GitHub, and we can create this pull request, following this whole process to ask for a review and wait for a reviewer to approve the change and merge. And then the process that we're going to have is that the user themselves is responsible to confirm the merge once approved. This just means that they're basically the ones pushing the big green button, and there's that sort of feeling of finality that your code has been merged into the main. So we're going to provide a template for these pull requests to make sure that everything is followed the way that others would like. So what about conflicts? So I've recorded a short video on merge conflicts, so we'll put that in after these slides, but I'll just give you a quick example of what this is. So a merge conflict is when Git cannot merge two versions of the same code together automatically. So Git has an interpolation strategy to be able to reconcile changes, and it can be fooled and it can break. So a conflict is resolved when the file or code in question, the offending code we can call it, looks exactly as the developer wants. And this is called resolving the conflict. So they can be triggered when the same lines of code are modified by two or more developers simultaneously. The changes have been made in both branches you're trying to merge. Files have been renamed, moved, or removed without the proper commands, white space or formatting changes. And yes, this is a difference between Unix and Windows. There are line endings that can cause issues. A developer deletes code another one's working on. If the commit is so big and convoluted that Git can't figure it out, particularly if the commit references code that is out of date and is well behind the main, this is why it's good to keep those commits short, those issues short and frequently merged. And there's a whole bunch of other things that can trigger a merge conflict. So you typically won't know you have a merge conflict until you attempt to push or pull changes from a remote repository and you're attempting to merge the different branches locally. So it's good practice always to pull first to get the most recent changes, then push. Git marks the conflict with a yours versus theirs syntax, which looks like this. So what you need to do is open the offending file, reconcile those conflicts by editing the offending code and commit boundary syntax. We want you to stage and commit those changes and then push them. And that's basically what that example will cover in the video. We've covered what happens when things go to plan. Now we're going to show an example of how to deal with a merge conflict. So a merge conflict, which I've given examples as to when they can arise, is where two developers are essentially working on the same piece of code in the same place, and Git doesn't know how to reconcile those changes, which one is authoritative. So in this example, I've cloned and checked out the repository twice in two different locations. So I've affectionately called them player 1 and player 2. And we're going to follow the workflow of how to A, trigger a merge conflict, which you never really want to do, and B, how to resolve it. So first things first, using our commands from GitHub, we're going to fetch the origin. And I've just pasted this, that's why it's showing it. And I'm going to check out the test issue. That's for player 1. So if we have a look, player 1's ready to go. And we'll do the same thing over here for player 2. Git fetch origin. Check it out. So both of these players are currently in the same place. Now let's see what happens when we both create a file, but with different content. What happens? So if we go, let's say echo, this is a conflict, and we'll call that conflict.text. Okay, so player 1 now has this. So git status, Good. We'll add it. Git add conflict.text and git commit added conflict.text. Okay, so that player one has created this and committed it, and we now have a conflict. Now, if that person then pushes it, so git push, that now exists up on the remote repository at this branch 13 test issue. Now let's see what happens when player 2 does the same thing. So let's create a file, echo, say this is my work. And let's put it in the same file, conflict.text. We'll git add it, conflict, git commit my work. Okay, so these people both have a conflict.txt but with different content in it. Okay, so let's see what happens when player 2 tries to push. So if we could git push. GitHub is rejecting that change because the tip of the current branch is behind its remote counterpart. So we need to do something with that before we try and push it. So Git's giving us some hints there. So we can say git pull. And what that's going to do is it's going to try and reconcile the changes. We have a conflict. Big letters, conflict. So there's a merge conflict in conflict.text, which is what we were trying to trigger. So the automatic merge has failed, so we need to deal with that. Now, how do we deal with those conflicts? So if we have a look at that file, so we've got conflict, we can see that this doesn't look like what we edited. So we have a difference, a syntax here, which is, I suppose that you can consider it commit boundaries, and there'll be multiples of these sections throughout the file wherever it differs in multiple files. So we have the head, which is what you're currently doing, versus the remote, which is that hash. So we can see that we currently say that this is my work, whereas the remote says this is a conflict. So what we need to do is we need to edit this file to make it look like what it should be. Now, some editors, like VS Code, for instance, will give you buttons to click saying mine or theirs, which can make it easier to understand which piece of code you want. But otherwise, it might actually be the amalgamation of these two things that you want. So each of you has some of the right answer. So we're going to edit this file, and we're going to say that both of those things is actually what we want. So we're going to delete the commit boundary. We're going to delete the divergence that is there. This is my work. This is a conflict. Everybody wins. Okay. So now we write that file out. If we do a git status, we can see that there is an unmerged path. So now that we have edited that, we can say git add conflict. And we can say git commit merge resolved. And now we should be able to say git push. And what this does, now it has accepted our change. So our change has happened after that after the original commit from player 1. We have resolved it, and now we're pushing it back up. So now if we were to go onto GitHub and deal with this process of doing the pull request and everything, we could actually resolve this and finish it off. So that is one way to account for issues where people are working on the same piece of code and we don't really know how to resolve it. So we're going to break things, then fix them. So if you do have someone to work with, you can follow this example, and this is what the video covers. So creating an issue, everyone follows these steps, you will be able to trigger and then reconcile a conflict. So if you do want to cover it, just pause on this, or you could just watch the video where I cover this. Housekeeping at the end of all this is once you have merged things on GitHub, you will need to clean up locally. So Git's not smart enough to clean up your branches locally. So essentially, we go through the process of listing anything that has been merged on the remote, and then we can delete those branches safely locally. And GitHub will be set to delete merged branches by default. And that is the end of the training where we aim to get to. Now, I do have a couple of bonus slides here, which I will cover through very quickly. So advanced topics, which you might come across in the wild, is, we have things called a rebase. We may want to talk about undoing changes and what GitHub Actions are. So a rebase is one way of avoiding manually merging by rebasing the current branch from another. So it does result in a different commit history, and it creates new commits to update the current branch. It can get very messy with long-lived branches, and please never rebase public history. So using that example on the right, if we consider that we branch off and do some work and then we merge in at some point, if we were to do a rebase, those dotted lines basically show us how the history will be rewritten. So rather than having this branch thing, everything will look linear and more intentional. Undoing changes, which we don't cover in the videos. Say we have put a typo in our commit message, we can use the amend command on commit, or we can change, changes that we have in the current changes we might want to combine with the previous commit for whatever reason. We can do that. We can recheck out files from the last commit and reset the changes we've made. Say we just want to go back to base 0 and start again. We can unstage anything and revert any changes, and we can revert. Now, there are additional arguments that you can give to these, which make it a little bit more severe, like hard resets and things like that. But just bear in mind, sometimes that it's cleaner just to create a new commit that corrects any issues. Don't be afraid to do that, because it does end up with a cleaner history, and it shows that we're all human, which is nice to know. And the last slide here is on GitHub Actions. So GitHub Actions are what we use to basically do our testing and code format testing, so code linting coverage, which tells us how much of the code is tested, doco generation and release, and code publication. So if you're interested, you can go check out GitHub Actions. But this is just something that we might have in place that will go through and check the validity of code, maybe even do a test compilation, things like that. And that is the end of the presentation. I hope you've followed along and enjoyed this, and you haven't fallen asleep to the drone of my voice. Have a great day. Cheers.